Hi there, I'm Hao, and today just another video of me solving random number problem. So today we have like an extension of the permutation 2, where we have to return all possible permutation, unique permutation, right, in any order. And then the difference is that now we have duplicate. Okay, so let's look at an example here. If we have like 1, 2, 3, right? So we can either choose pick 1, 2, or 3, right? If we pick one, we only have 2 or 3 left, right? So we either have to go with 1 or 3, right? 2, 1, or 2, 3, and then 3, 1, or 3, 2, right? So on and so forth. So 1, 2, and 3 here. This one is 1, 3, and 2, right? So this is our original approach, right? So as we pick a number and go to the next recursion level, right? We will pick the numbers that hasn't been included in the current array, right? And when we see that the length of the array is equal to the input nums array, right? Which means we found a permutation, so we can just go ahead and add this permutation as a copy into our results array, right? And we make a copy because we try different number, right? But we go 1, 2, when we return back up, we will pop up the 2 here, right? When we go down, we add the 2. When we go back up, we pop up the 2 and try with the next number, right? Which is 3. So that's why we need to create a copy because we will mutate the array later on. Okay, so that is one thing. So the problem now is that because previously we only try the numbers if the number is not already in the array, right? So if we have 1, 1, 2 here, right, we have duplicate, which means that the second one here will never be included in our uh, permutation. So we can do 1, 1, 2, right? And then this is if we do 1, right, if we have 1 and 2 left, but we cannot pick this one, right? Because 1 is already in the current array, right? So how could we do with this? So we can have a hash map. Actually, we have a hash map to keep track of the occurrence of the letters, right? So before we even start the backtracking approach, right, we will iterate to the input array and keep track of the occurrence of each number. So the number 1 here occurs 2 times, and number 2 occur 1 time, right? So yes, as we iterate out, right, we just decrement the occurrence at once by 1, right? And we will go down one more time and do 1, 1, right? Can decrement this to 0, which means we only have one option left, right? We can do 1, 1, and 2. Right? And when we return back up, right? So 2 is now become 0, right? So when we return back up, we can add 1 back to 2. Right? We can increment the occurrence of 2, so we can reuse it again. Return back up, right? 1 now become 1, right? And now we can we already finished. We finished trying 1, so now we can try the next number, right? Which is 2. So 1 and 2, right? And we decrement count to 0, right? So now we only have one option left, which is 1. So you have 1, 2, 1, right? So on and so forth. So let's look at the next one here. So when we return back up, right, we are reset to original, which is 1 here, right? So we can pick one. And we can also pick two, pick 1 and 2. And so if we pick one, um, wait, so right, so if we iterate over the input number, right, we would run into this issues again. Right, let me change color here, where we have duplicates, right? So this can go down to 1, 1, 2 again, right? So we're gonna have this, which is uh duplicates. So the key to avoid this. So okay, uh, first of all, we use the counter, right? First of all, we use the counter because we want to be able to include a duplicate number as one of our results, right? Which is 1, 1, 2 over here, right? So one is 1 and 1 are duplicate, so they are still like a valid candidate, right? So we use that by having a counter, right? So we can just keep track of the occurrence of the one. So um, that would allow us to have duplicate in our result, like the duplicate numbers in one permutation, right? And how do we avoid this duplicate? So instead of iterating over the original input number, we can iterate over our hash map, right? So if we iterate, because I want to show this to see to show the problem of iterating over the input result. So instead, we will iterate over the hash map, right? We always give us the unique numbers here, right? 1 and 2. So in that case, we will never run into the duplicate issues again, right? So if 2, we're gonna have 2 and 1, right? If we pick 2, 2 is 0, right? We only have one option left. If we pick 1, then we only have one left. So 2, 1, and 1, right? It's become 0, right? And we return. So we're gonna have like 3 answers. Okay. So again, there's two things that we did differently compared to the original permutation, right? So the first thing is that in the original permutation, we will iterate through the input number, right? And add the number that is not yet included in the current array, right? But in this case, because we can have duplicates, our permutation can have duplicates, which means we cannot use that approach. We use a counter, and instead we use a counter to keep track of the occurrence of every single number, right? So that every time we pick one number, we're just gonna decrement the count until they are 0, right? If the count is 0, we're just gonna ignore them, right? So in that case, uh, we are depending on the occurrence, not the unique number itself, right? So in that case, we can have repetition in one of our permutation, right? And the second thing that we did differently is that um, instead of iterating over the original input, the input nums, right? We iterate over our hash table, right? Because iterating over a hash table give us the unique key, right? So that we can avoid the duplicate results, right? So we want duplicate in our permutation, but we don't want duplicate permutation, right? Which is 1, 1, 2, 2, 1, 2, 1, right? So we're doing that by iterating over our hash map to give us a unique key instead of iterating over the input nums. So that is the two different things that we did, right? The runtime gonna be the same, right? Permutation is n factorial because every time you pick one, you have like one less option, right? Um, and then every time we file a permutation, we need to add it into our result array, and we need to make a copy, right? So that is O of n. So that So our type complexity would be n multiplied by n factorial. Okay. The space complexity would just be of n, right? Because we be our hash table. Okay. And that's pretty much it. Let's just code this up. Right. So we're gonna have our results, of course. Then return the results at the end. We're gonna have our hash table. So okay. And the low nums are for each num. Right. If num is in outer, right, then outer at num plus. Otherwise, outer at num equal to 1. So here we keep track of our code. And now we can start the backtracking as usual. Right. We tag in the array, if the nums of length is equal to the array of length, right, we want to return and we want to push it into our resource array. We want to push a copy, remember? Because we are mutating our array, right? Every time we pop up, every time we return, we're gonna pop up the last element, right? Okay, and then we're gonna iterate over each number. And remember, we're not gonna iterate over the original input array, right? We want to iterate over our So let me just write it down here. We want to iterate over our hash table, right? Now we can have the unique key for num in counter, right? So if the counter of num is greater than 0, we do something. If it is less than or equal to 0, we're just gonna ignore, right? Right. So using the occurrence here, remember, allow us to have duplicate in our permutation, right? But iterating over the unique key here, avoid duplicate permutation. So that's different, right? We can add the element, so num, right? We can pop it up, right? And then we can call our back function, I think in the array. Okay, so there's one thing else we need to do here, is that we need to decrement the count, right? Every time we push and then increment the count back when we pop it off, right? And this is pretty much it. Let me try this. Okay, a typo here. Num m not w. Oh yes, d should be outside. What am I doing? Okay, and thank you for watching.